recording. Okay, so in topic 3, homework 2, question 1, we have this null hypothesis and this given factual information, and we're supposed to calculate Z. And I need to do that before I draw the picture. I want to get around to how to draw the picture. So anyway, Z is the x bar minus mu over sigma over root n. So that's 2542 minus 2500 over 0.4 over the square root of 51. Okay. So let's see. I'm gonna do that, and I guess I'll do that in Excel. So I'll do my $42 on top. That's 2542 minus 2500. So I got my $42 on top, and on the bottom I have, oh, my standard deviation was 109. I wrote that wrong, 109. It didn't make any sense. That was a different problem. So it's $109 over square root of 51. And so I get 2.75 STDs, roughly. Okay. Okay, so now all we have to do is draw the picture. So the picture of what? Well, for finding the p-value, what we need is a picture of the distribution of the sample mean. So the distribution of the sample mean, assuming the null hypothesis was true. So if the population mean was really that 2,500, then the 2,500 would be right in the middle. And that would be 0 STDs. Now our sample mean was 2542, and that's 2.75 standard deviations. So if this is one standard deviation here, and here's two STDs here, then, you know, every time, if you repeated this experiment many times, you get all different sample means. But ours, this one time, happened to be 2542. Now that was 2.75 STDs. So that's 1, 2. It's over here getting pretty near the edge. So I doubt you can see this, but I'm trying to write a capital X over here for the random variable that takes on all different values. And I'm writing the little lowercase x here for our specific value today. That was 2542, or a z-score of 2.75 right there. And then what's the p-value? So it's the probability that we would get such a big sample mean just by chance if the population mean was way over here at 2,500. This probability would come out so far above, our sample mean would be so far above the population mean just by chance if the population mean was really 2,500. And so the p-value is the shaded area here. Okay. And how much is the p-value? Well, I can use the norm.dist function. But it'll give me the area to the left of whatever I plug in. So I want to do 1 minus that area. 1 minus the big white area gives you the remaining blue area. Okay. So it's 1 minus the probability that the capital X bar would be less than 2542. And at this point, there's 2 ways you can do that problem. I can do 1 minus norm dist of 2542, the mean 2500, standard deviation 109 over root 51, and true. Or I can do 1 minus the standard normal dist, .75 STDs. I don't have to type in the rest because when you use the standard normal, you already know, and for the z-scores down here, the standard deviation is 1 and the mean is 0, so you don't have to type that in. But either way, we'll get the same number. So let's put that in Excel. Equals 1 minus norm dist of this guy. And you see, when I'm using Excel, I rarely type any numbers. I click on the cells that I've already got, because then I get all the digits. Oh, and I got to say true to make the area. So And I was trying to say norm.s.dist. Okay. And so there I get my p-value. Okay. So put my p-value over there, and it's about 0.3%. Let me format that. I'm going to change it into a percent. And then I want to show to the nearest tenth of a percent. So round it off at 0.3%. And from a calculator input, I come over here. And over here in Adobe, I'm going to, I'm just going to type 2.75, but when you see numbers typed like that, even in a real publication or an engineering paper or something, you need to anticipate that they rounded it off. And when they did the real calculation, they would have kept all the digits, and they're just not showing them all here. So that's the way it works. So what are the elements of the picture? What has to be, what do I look for? If I'm grading a test, try to figure out what's there. It's got a title. It's got an axis label. It's got units. It's got a scale. I've marked off the scale here in STDs. I have not marked the scale in the natural units. And it's hard to make them both to be nice numbers. But let me I'll go back and do that. Let me see if the instructions said anything specific there. It did not. So for grading the homework, I wouldn't ding you on that, but on a test, I'd probably be more specific and say mark the scale. And so let's see. Standard deviation of this curve. This distance right here. How much is that? It's $109 divided by the square root of 51. So let's see. So that was 15.26, $15.26. So this is 25, 15, 26 here. Let me. Okay. All right, I think I'll stop this recording. We'll do another one about something else.